So the next one looks like the following. We have the integral of x times the square root of x squared plus 2x plus 4 dx. Okay? So, do tell me what to do here. Oh, wise people, do give me your advice. Where shall I go from here? Wow, that was quick. Complete the square. That's very good. That's a very keen observation. We have done something like that before, right? We want to start by completing the square. And the reason behind that, if you look at the tables, you can find the square root of trinomials in any of the references. However, you'll find plenty of square root of binomials, such as x squared minus a squared, or x squared plus a squared, or u squared plus or minus a squared. So we want to convert this trinomial into this form. So we complete the square, and we'll say that x squared plus 2x plus 4 really equals to x squared plus 2x plus 1, which is a perfect square trinomial, because this one equals to x plus 1 squared, right? So it's x plus 1 squared plus 3. Wonderful. So what do I do next? Completed the square. So what will be the next step? No, because you have the square root of x plus 1 squared plus 3. You are stuck with that 3. Use substitution. Go ahead. Tell me what to substitute. U by substitution. How about I'll use different variable? I'll use z. Ooh.
The square root of.
I'll stop right there. Because we want the square root of z squared plus something else. Because we have that in our table. Okay? So, but we need to also substitute for x, right? So from here you get x will be z minus 1. And also we need to have something for dx. So dx equals dz. All right, so let's see what we accomplish. Our integral, let's call it I. Originally, x times the square root of x squared plus 2x plus 4 dx. After redressing it with a z substitution, it's the integral of, instead of x, we have z minus 1. And the square root now becomes, we have z squared plus 3, so it's the square root of z squared plus 3, and dx is simply dz by the way we set it up right here. Okay, so we have this deal right going on here, and again, I'm asking for your advice. What will be my next step?
Factor out the z minus 1, you can split the integral.
Split the integrals. So not factor, but...
Well, I mean, sorry.
Right.
Expand it, then you can that.
Right. Good. So it would be the integral of z times the square root of z squared plus 3 dz, one integral, and then another integral will be minus the integral of simply the square root of z squared plus 3 dz. Good. So what do we do next? Already? Can't we do something simpler here? We can, probably there is something like that in the formula, but maybe we don't need a formula here, perhaps.
What is the inverse signs?
You can write it as z dz times, or the square root of z squared plus 3 times z dz. and z dz. If you do another substitution, you don't see it? Right. Exactly. Okay, so here we're going to use this, we look at the table, but for the first integral, so let's see, the first integral, we let u, that's why I use z, and then now I'll go to u. U equals z squared plus 3, and therefore du equals 2z dz, and simply z dz, which we have here, we have z dz, is simply 1/2 du. Okay, so the integral, the first integral, z times the square root of z squared plus 3d dz becomes, we pull out the 1/2, and then we have the square root of u, or u to the 1/2 du. This is easy integral, right? Add 1, so you get 3/2, and you divide by or multiply by 2/3, so you have 1/3 u to the 3/2. And if you want to bring it in terms of z language, so it will be 1/3 z squared plus 3 raised to the power of 3/2. Okay, so this will be the first integral. What about the second integral? So let's mark this like that, and another one right here with so the integral of z square root of z squared plus 3 dz is simply 1/3 z squared plus 3 to the power of 3/2. So this will be our first substitution, so we'll mark it like so. The next substitution, now we need to deal with this integral. So, what say you?
Use
Formula 21? Okay, so what Formula 21 tells us? Gee, lots of stuff, huh? Actually, we have a negative up front, so let's keep the negative up front. Can you do the negative adjustment here? Let me write it on the next page. So basically, the only adjustment we need to make, replace, keep z instead of u and put the negative sign up front. So at this point, it looks like we have negative z over 2, okay, the square root of z squared plus 3 plus 3/2 the natural log of z plus the square root of z squared plus 3. Right? So putting everything together, so now the integral Okay, and this one is the result of the second integral. Okay, so now we put these two together, and we have I, the integral, is from the first part is 1/3 times z squared plus 3 to the 3/2 plus this thing right here that we just came up with from formula 21. Now to complete what I'm writing, let me see if I can write and talk at the same time. Okay, and then you have plus c somewhere here. We want to bring x back to the equation where we started. So we have z squared plus 3 in 3 locations. What is z squared plus 3 in terms of x? Exactly, the original one. Remember, that's where we obtained z squared. Well, z is x plus 1, so we have x plus 1 squared plus 3, but that's the result of the completing the squares. So it's the trinomial x squared plus 2x plus 4. So every time we see z squared plus 3, we're going to write x squared plus 3 plus 2x plus 4. Here we have z, so it's x plus 1. This is a long one, isn't it? There we go. So